Welcome to today's episode of Evil Magic and Dark Arts featuring the Calculus Crew. Today, Spencer Salone is going to introduce us to derivatives.
Have you ever wanted to find a function that'll give you the slope of another function? Me neither. But this year I had to learn that calculus, and today I'm here to teach you how to do a derivative.
Okay, so suppose we have a function, y equals anything. We'll just make it y equals x squared to keep it simple. So we know what y equals x squared look like. It's a parabola going down. It's like a big U that goes at the origin. And we want to know, suppose we want to know the slope of it at any point. What we needed for that is a derivative. And we call those y prime. We draw it like that with a y prime. To find a derivative, though, we have to do some math. And usually that means we got to find the slope. So the slope is, it's rise over run. They always say rise over run. That's the slope. So we're going to have to find the change in its y value, called delta y, over the change in its x value, delta x. Now with that, what we can do is we can either get an average of it, which is, we can say, oh, we want to know its slope at 2. Then we can put, the difference between 0 and 4, so we can get the y value of 4 minus the y value of 0, that's a change in y, and then divide it by the x value of 4, which is going to be 4, divided by the x value of 0, which is 0. And that'll give you, the average rate of change over that point. But with the derivative, we want a continuous function that's going to show us the slope at all points in between there exactly, not average, exactly.
Alex, you were saying some pretty tricky stuff just now, but I think I know where you're going with this. Alex, why don't you tell us how we get a derivative function?
Boy, I'm glad you asked. I'm going to tell you about it. That's good. All right. So when we want to find a derivative, we start off by we write down the original function that we're trying to find the derivative of. In this case, we already said it was y equals x squared. What we do with that is we then transform it. We just do a couple things to it, and it makes it the derivative. Magic. It's magic. What we do is we come down, we take the x squared, and we move whatever it's raised to, the derivative, the variable letter that we're trying to find the derivative of, in this case x. We take whatever it's raised to and we move it to the front. So it becomes 2x. Then we subtract 1 from the exponent. So that leaves us with 2x raised to the 1, which is just 2x to the 1. I mean, just 2x, So we know the derivative now, y prime equals 2x. Y prime equals 2x. So the graph of that is going to be, we know it's just a linear function with double the slope of a regular. And if you look at it, it really is a graph of the slope of the original function. It becomes positive at the same time the slope of this becomes positive.
Wow, Alex. That's freaking magic.
It might be a lot to learn, in one sitting, so we'll go over it one more time, and this time a different way. Maybe see if you can help you understand. So you have a function, and this is in terms of x, f of x. It can be any letter, y'all know. X raised to the n, and we want to find the derivative. So we write f prime. The derivative of that is going to be, you're going to have n becomes a new coefficient, so it's going to be n times x raised to the n minus 1. That's how we got 2x as a derivative of x squared. You move whatever the exponent is to the front. X squared becomes 2x squared. Then you subtract 1. That makes it 2x to the 1. So you just get 2x. This works with anything. If you had, just y equals x, then it'd become, it'd just be 0. Your slope would be 0. Oh, no, it'd be 1, right? What'd your slope be?
Yeah, fine.
It'd be x. Do it real quick. Write it out.
It does work with everything. What's the derivative of y equals x? It's 1, right?
Yeah.
Yeah, it is 1.
But we already knew that, though. We're just testing
Yeah,
out.
we wanted to know if you knew more than us.
I think this video is good. I think we can stop it.